Okay, we have a question and linear motion, which you can call kinematics, because kinematics and linear motion they're the same things. So the question is saying the thickest and strongest chamber in the human heart is the left ventricle, responsible during systole for pumping oxygenated blood through the aorta to the rest of the body. Assume aortic blood start from rest and accelerate at 22.5 meters per second squared to a peak speed of 1.05 meters per second. How far does the blood travel during this acceleration? Then they are saying that the answer is supposed to be in millimeters. Okay, so now what we have to do is we know that we have three main equations of linear motion. We have v final is equal to v initial plus acceleration times time. The displacement you can say d or s is equal to the v initial times t plus half acceleration times t squared. Then the third one is v final squared is equal to v initial squared plus 2ad. Now, it is very important for us to come up with data first. Data is going to help us to know which equation are we going to use. So let's first come up with data. So from the data here we can see that we have been given the acceleration as 22.5 meters per second squared. We have been given the initial velocity. It started from rest, so the initial velocity is 0 meters per second. The final velocity we have been given that to a peak of 1.05 meters per second. Okay, then what else do we know? These are the only thing we know. We want to find the displacement, which we don't know. So we don't have time, therefore the first formula can't work out. The second can't work out because we need time. So these two can't work out. The only formula is going to be the third one. So we're going to use the third formula for us to find the displacement. Okay. So what we're going to have is the v final squared is equal to v initial squared plus 2ad. So d, it can be represented by s. Sometimes it can be represented by change in x. So change in x, we are talking about the motion in x direction. When you talk of the freeform motion, you're going to say that some box they are going to tell you that the displacement is the same as change in y, because we're talking about the motion in y direction. So in this case you can say it is change in x. You can use d or s. Okay, that is just the same thing. So the final velocity is 1.05. We square it. This has to be equal to, we have the initial as 0, it started from rest. 2, the acceleration is 22.5, then we want to find the d. So we are going to say that 1.05, we square it. This is giving me 1.1025 has to be equal to, then we're going to have 2 times 22 point, we have 22.5 times 2 is 45, so we have a 45 d. So our goal is to find the displacement. We are going to divide both sides by 45, both sides by 45. So these they will cancel. We'll have our d to be equal to 1.1025 divided by 45. This is going to be 0.0245. Okay, now this is in meters. Now the question is saying, this is the answer, but the question is saying our answer is supposed to be in millimeters. Now to convert meters to millimeters, you just need to do times a 1000. Now if maybe you're having some challenges using this conversion, what you can do is in 1 meter there is 100 centimeters, and then in 1 centimeter there is 10 millimeters. So now what it means there is that you can either convert this to centimeters, then after that convert that centimeters into meters. That is the same as just saying in 1 meter There is 1000, because if I do 10 times this one, it's going to give me a 1000. There's 1000 millimeters, which is just the same thing, right? So you can either use this direct, or you can convert first from millimeters to meters and then back to that one. But here what we're going to do is we're going to convert it direct. So we need to do this times a 1000. So we're going to say that 0.0245 times a 1000, which is going to be a 24.5. So our distance is 24.5 millimeters. So that's the answer for this question.